today we are going to start chapter 7.4, part 1. This is part 1 of 2 videos. So today we are going to talk about the remainder theorem. And in doing the remainder theorem, we also need to remember synthetic division, which we learned way back, maybe in chapter 5, I think? I don't remember. But we have learned it before, but we'll go over it again. So the remainder theorem says, if a polynomial f of x is divided by x minus a, the remainder is the constant f of a. Okay, that's a lot of wordiness, but basically it's saying that if you take a polynomial and you divide it by a root, or by a factor of that polynomial, then the remainder of it after you divide it is the same thing as if you just calculated that function at that certain point, which I'll show you an example. So here, if we have f of x equals 4x squared minus 3x plus 6, and we're going to divide it by x minus 2, okay, we're going to use synthetic division. Now synthetic division, if you remember, we set up this little box right here, and inside that box goes our 0. Okay, and the reason why we have that 0 is because we're taking what we're dividing by, so this right here, and setting it equal to 0. So if we set x minus 2 equal to 0, add 2, we get x equals 2. So here, that's why we're putting 2 in that box right there, because that is the 0 that we're dividing by. Okay, and then we take the coefficients in descending degree order. Okay, we're going to do our next example, we're going to do one where we skip a degree. Here we go 2, 1, 0, which that's fine. We're just going to drop the 4, negative 3, and 6. But it's important that if we start at degree 2, that we have to take into account every single degree from there going down to 0. We'll get to that in the next example. Okay, so here is our 0, and here are our coefficients. Okay, the first step is that we take this first coefficient and we drop it below the line. Okay, when we're below the line, we multiply. Okay, so this 4 is below the line, so we're going to multiply it by the 2. So 4 times 2 is 8. So I put the 8 in the next spot. Okay, and then I add these two numbers. Negative 3 plus 8 is 5. Now 5 is below the line again, so I'm going to multiply it to my 0. 5 times 2 is 10, and then I add those two numbers. 6 plus 10 is 16. The last number right here is your remainder. Okay, that's your remainder. Since we're dividing by x minus 2 here and our 0 is 2, the remainder theorem says that this remainder is going to be the same thing if you were to evaluate this function at 2, which is what we did in section 7.1. So if we look at this, if we just go ahead and calculate f of 2, that's our 0 here, that means that we're going to plug in a 2 wherever we see an x. So 2, 2, 2. Okay? So we are going to have 2 squared, which is 4, times 4 is 16. 3 times 2 is 6. We're going to have minus 6, plus 6. 16 minus 6 plus 6, those cancel out. We're left with 16. Look! See? They're both 16. This is our remainder theorem. That's what the remainder theorem means. So when you can do synthetic division, which is much quicker, and with the leftovers that you get would be the same thing if you were just to evaluate it. Okay? So now we're seeing two different ways to do the same thing. One is much faster. Let's do some examples. Alright. Here we have, if f of x is 2x to the 4th minus 5x squared plus 8x minus 7, we want to find f of 6. Okay, using our remainder theorem, this says that I can synthetically divide that polynomial at 6. Okay? So this means that in my little box, here my 0 is going to be 6. Okay? Now I'm going to take all my coefficients and line them out. So here I have my x to the 4th coefficient, which is a 2. Now since I started at x to the 4th, I have to take into account every single degree following thereafter. Okay, so x cubed, look, I have no x cubed in this problem. I have to put a 0 here. If I do not put a 0 there as a placeholder, I'm going to get a wrong answer. So you have to take into account every degree. When you start at fourth, you have to do third, second, first, 0. Okay, x squared, we get negative 5. X to the first is 8. And then x to the 0 is negative 7. Okay, first step, we drop this first number below the line. When we're below the line, we multiply. So 2 times 6 is 12. 12 plus 0 is 12. 12 times 6. Get out your calculators. That is 72. Negative 5 plus 72. Oh dear goodness. I need my calculator. Spring break. My brain's not working. That is 67. Positive 67. 67 times 6 is 236. 402 plus 8 is 410. 410 times 6 is 2460 plus a negative 7 is going to give you 2,453. So this, f of 6, equals 2,453. Voila. Lovely, isn't it? So remember, when you're below the line, you multiply. When you're above the line, you just add. Okay? Because I'm in such high spirits since it is after spring break, I will offer you some extra credit right now. I want you to either comment or bring in your responses to class before class starts on one thing that you did that was math related over spring break. Yes, one math related thing. Let me. Okay, here we have g of x equals x cubed minus x squared plus 4x minus 4. And we're finding g of negative 3. So this number is going in my box. And now I'm dropping coefficients. So if I'm starting at x cubed, I have to take into account x squared, x to the first, and x to the 0. The coefficient in front of here is a 1. The coefficient in front of x squared is a negative 1. Coefficient in front of x is 4. And my constant at the end is negative 4. So I'm going to drop my first one, which is a 1. When I'm below the line, I multiply. 1 times negative 3 is still negative 3. Then I add. Negative 1 plus negative 3 is negative 4. I'm below the line, so I multiply. Negative 4 times negative 3 is 12. 12 plus 4 is 16. 16, I'm below the line, times negative 3. That's negative 48. Negative 48 plus a negative 4 is negative 52. So g of negative 3 equals negative 52. There you have it. Okay?